Okay, today we're going to look at areas of different shapes. The first one we're going to begin with is a rectangle, nice and simple. As you can see down here, we have the rule, area equals length times width. Now what we do is we look at the length, which is 9 centimeters, and the width, which is 5 centimeters, and we put basically those two in substitution with L and W. So what we end up having is A equals 9 times 5. Now that just simply means going down here we've got break it into 5 centimeters, across here breaking it into 9, and that gives you basically 45 squares set into that area, just basically like that. That gives you 45 centimeters squared. Okay, now if you're going to look at the perimeter of this shape, very similar. We just have to basically look at the 5, we look at the 9, so we've got length and a width. But in this case, we've got two widths on either side, two lengths on the other side. So basically what we need to do is do length plus width and plus width. The easier way to do that is 2L plus 2W. That ends up looking like this. So perimeter equals 9 plus 9 plus 5 plus 5. So if you quickly do your maths, it equals 28 centimeters. Now we don't need to put the square in there because we're talking distance, not area in that sense. Moving forward. Okay, we've also got a square. It's very similar to the rectangle, but in this case we've just got a length, and length, which means basically we're looking at length square or L times L. In this case our L is 6, which we get from down here. Now each of these lines show that each side is 6. Okay, they're all the same size. So what we're going to look at is area equals 6 times 6, or 6 squared. Now we know this is 36, okay, but we can't leave it like that. We still need to do centimeters squared just to make it finished off. The next shape, just as easy, it's a triangle. Okay, now we know triangles are basically half of a rectangle, so we need two things. We need our base and we need our height. Okay, the rule we're going to use is one of two. We've got area equals half times base times height, or I prefer this one here, which is base times height divided by 2. It's the same thing, but instead of dividing by 2 is the same as timesing it by 0.5. So either or, whichever one suits you. Now I'm going to use this one here because I think this is a much easier one. So what we're going to do is substitute base with our base, which is 7. We're going to substitute our height, which is our 10. And then we're going to divide that by 2. So area equals 7 times 10 divided by 2. And this simply gives you 35. Because we know this is 70. Divide that by 2 gives us 35. Nice and simple. Now if you're going to do a perimeter on this one, you do need to know the base and you need to put these two together. But if you're asked that, you'll be given those measurements. Now trapezium, this one might be new to you. There is again two rules that we can use for this one. But the things we need to know here is basically we've got three things we need. We've got measurement A, measurement B, and height. Now A is the roof, B is the base, and we put all those together in these two formulas. Well, you can choose one. Okay, so we've got half times A plus B times by height. We can also do this one here where it says or A plus B times height divided by 2. This one here is what I prefer to use. So we're going to jump onto this one and use this rule here. So we've got A equals, now we've got our A, which is 4 plus our 10 Okay, we're going to put brackets around that because of BODMAS. We're going to times it by height, which is 5. Then we're going to bring in our divided by 2. Now divide by 2 is the same as saying times by half. Just an easy way of looking at it. So 4 plus 10 is 14. We're going to times that by 5. Now we know that it's equal to 70. Okay, but we're going to divide both divided by 2. So we know straight away 70 divided by 2 is 35 centimeters squared. So really, really nice and easy way of putting it. Moving forward, okay, parallelogram. So what's special about a parallelogram is we've got two sides. This one and this one are parallel. This one and this one are parallel to each other. So these are the same as this one, and this one is the same as this one. Okay, so the base is the same length as the height in this case. Alright, so the rule is nice and simple. We're going to use area equals base times height, just like a rectangle or a square, something like that. So the first thing we're going to do is substitute our numbers. We've got base and height. So our base is 9, we've got our height which is 6, and we're just going to times them together. Okay, so 9 times 6, nice and easy, equals 54 centimeters. Now we have to include the square because we're talking area, but that's basically as simple as it is. Now we can't times it by the height here, so if you're given the measurement here, if you use that you're going to be wrong because that can stay the same but the height can change. So it just means it's going to look flatter. So you have to use this measurement here. Okay, next shape is a circle. Now a circle is quite easy. In this case we're looking at area, so you need to make sure you use the right rule for this one. The area of a circle is pi times r times, squared, sorry. So that looks like this one here. Pi times radius squared. Now I've put on here both radius and diameter. Now diameter is from side to side, but it has to pass directly through the middle. Radius goes from the middle to only one side, does not go all the way through. So radius, and I'll put it down here for you so you can remember, radius equals diameter divided by 2. So it's the same thing, but you just divide by 2. So 20 divided by 2 gives you your radius, in this case 10. So what we're going to do is we've got pi. Now I'm going to bring pi up here so you can make sure you can see. Pi equals 3.1416. Okay, so you can round it off to 3.142 if you like, but it continues forever basically, so we'll just take it to 4 decimal places. So we've got pi times radius. Now in this case it's 10, but because of the square it's basically saying 100. So pi times 100. All we're going to do with our decimal place is move it 2 spots. 1, 2. I'm going to put it right there, okay, because we've times it by 100. Now it doesn't work always that easily depending on which number our radius is. So pi times 100 equals 314.16, and then we've got our centimeters squared. Now you have to be careful on this one, just in case you're doing perimeter. Okay, now we call that circumference, so you shouldn't have a P, you should really have a C, okay, for circumference. Now the circumference can be 2 pi r or pi times diameter. So it's nice and simple. 2 times pi times r is exactly the same as pi times d. Instead of making the 20 into 10, just keep it. So, but that's only circumference. Do not do that for area. Alright, I'm going to pause it there. I'll come back to you. Okay, here we basically work like it is a circle. But in this case, we've only got a part of a circle, so we have to act like it is a part of a circle. The way we do that is we actually look at our little bit of our section here. Now what this bit, oops, my pen's not working. What this bit is showing you is that it's the breakdown. It gives you the percentage of the circle that we're looking for. And this little symbol is talking about the angle that we're using, which is this bit right here. Okay. In this case, we're going to make that angle 20 degrees. Okay, so we know what it is. We also know that our radius is 10. Why do I use 10? Because it's just really simple to be able to square. Okay, so the first thing we need to do is actually set it out like this. So we have the amount of degrees that we're using over 360, because there is 360 degrees in a circle. So we're only using 20 degrees of that circle. Okay, this just gives you the percentage. Well, basically, it gives you it in a decimal form though. Okay, so just have to remember that. Now, basically what we're going to do is we divide 20 by 360. Now that gives you 0.556 as an answer. Okay, so that's going to be what this equals. In the end, all we're going to do then, now you can put that in the calculator as 20 over 360. Then we're going to times it by pi times your radius. In this case it's 10 and squared again. Okay, now we know this equals 314.16. Okay, so we put all that into the calculator like we showed you before, and it ends up being 17.45 centimeters squared. Okay, so we get our decimal by doing the division here, times it by pi r squared, and you get your answer. Alright, so this one's slightly bigger. As you can see, it's pretty much 3/4 of the circle. Okay, now when I say that, we're using 270 degrees. Okay, so it's quite often will be given to you in here. You'll have it, see it written down. Okay, so we first of all need to find the decimal, okay, that we're going to be using to find out how much of that circle we're doing, because it's not a full circle. So first of all, in your calculator, you're going to put 270 divided by 360. In this case, it equals 0.75. Okay, it is 3/4. Okay, then we put in times our pi. Now I'm going to make this radius 5, just for something different. So in here we're going to have 5 squared. Now we know this is 25. So you're expecting pi times 25 to be roughly 75, a little bit over, maybe 78. Okay, so you put that into the calculator, 0.75 times this pi r squared, and basically you press equals and you're going to get your answer, which is going to be 58.9. Now it is a little bit different, as in it goes 0.04, but it's not going to change. So I'm rounding up to 1 decimal place, and make sure you put your centimeters squared, otherwise you won't be right. Now our rhombus. A rhombus is basically a kite. Okay, so there's two things we need to know for a kite. We've got X and we've got Y. Now the Y, it doesn't matter which way you have it around, but Y is basically from this point to this point, and your X is from this point to this point. So I've given you, in this case, we're going to say let's have X as 5 and Y as 3. So all you're going to do is substitute the numbers that we have here into this formula here. So X goes there and Y goes there. So what we're going to have is area equals 5 times 3. Okay, we're going to divide that by 2, then we're going to rewrite it. So 15 divided by 2. Now if we solve that, it becomes 15 divided by 2 is 7.5, and don't forget your centimeters squared. Now nice and easy, it's not a square, it's not a rhombus, so we have to divide it by 2. Okay, as you can see, it's 2 triangles still. Okay, so a little bit different. Okay, moving on. Here we have the ellipse. You guys might see it as an oval. It could be an egg shape, but an oval is usually what we'd call it. Okay. Again, there's two things we need to know. We need to know our A and we need to know our B. So we've got A here and we've got B. So all we're going to do is nice and simple. We're going to get area, we're going to go equals, we're going to have pi again, so 3.1416, and we're going to times that simply by 2 and by your 3. Now I'm going to leave that one for you because I think you guys can do that. Alright, so what I want from you is, for now, you're going to actually come in and give me that answer. This is what you have to do. Alright, so I'm going to move on. Okay, so now we have a new shape. Well, not a new shape, it's a triangle. But in this case, we're not given the height like we were given in the other triangle. However, in this case, we've been given three other bits of information. We've been given this side, which we're going to call A. We're going to give this side, which we're going to call B. And we're going to have this one, which is called C. Now, in this case, we're going to use Heron's formula. Heron's formula is, as shown here, square root, which you can find on your calculator. Now, I did make a mistake. This has to be a bracket here, okay, and not here. So we're just going to do that. Now, what we're going to do is have S take away A times S take away B times S take away C. Now, at this stage, I haven't told you what S is. We know what A is, we know what B is, we know what C is, but we need to find out what the S actually is. So what we're going to do is, first of all, look at this one here. This is part A. Now, or part 1. This one is part 2. Okay, so first of all, we're going to find S. All we're going to do with S is use the formula A plus B plus C divided by 2. So we're just going to simply write it out. We're going to have 5 plus 3 plus 6 divided by 2. Now 5 plus 3 is 8, plus 6 is 14. Divide that by 2, so S equals 7. Now all we're going to do is substitute that 7 into where the S is. So I'm just going to rewrite that here. Now we've got 7, take away A, which is 5, close that bracket. We're going to open another bracket, 7, take away B, which is 3, and then we're going to do 7, take away 6. Okay, and you're going to set it out like this. And I want you to do that. I want you to show you working out. So we're going to rewrite it again. We're going to have 7 take away 5, which is 2. We're going to have 7 take away 3, which is 4. And we're going to have 7 divided take away 6, which is 1. Now when you add this up, 2 times 4 is obviously 8, times 1, which is obviously still 8. Now the answer is going to be square root of 8. Okay. Now I'm going to let you give me the answer there. Okay, that's part of your homework, is to actually tell me what that answer is. Don't forget centimeters squared. Okay. Now, here we have total surface area. Total surface area is very, very different in the sense of what we're going to look at is unraveling this bad boy. You're going to end up having a thing like this, a net, okay, with all the different sides attached, like so. Now we know this side here and this side are the same. We know this side here and this side here is the same. Then we've got this side, but yes, we do need to have 2 of these sides. So I'm just going to put that down here, like that. So that and that side are the same. Okay. So what we're looking at, we need your length times, well, your width and your height. So length, we'll just call it this one. Width, we'll call this one. And height, we'll call this one. It doesn't really matter. Okay. So the rule we're going to use in this case is 2. We're going to, in the brackets, we're going to have length times height. Now that's going to show basically this back wall here. We're going to have length times width. We'll just say it's that one there. And we'll have our width times height. So we'll say it's the top one. Okay. So you're making sure, and then you've got 2. So you're making sure you have every side covered. Every area is covered. Okay. So this might be area 1, this is area 2, and this is area 3. So they're all added together. We times by 2 purely because we have 2 lots of each one. So what we're going to do is we're going to make length maybe 4. We'll take width, which can be 2, and we'll make your height, which is 3. Nice and simple numbers. So what we're going to do is substitute these numbers into this equation. So we're going to rewrite it 2 times length times height. So we know length is 4 times height, which we set 3. We're going to have a plus, so we're going to just put that in a bracket just to make it easy. We're going to have length times width, so 4 times 2. Now you'll be noticing that we're using each one twice. We're going to do this. So basically you can see that length is times with height and width. Width is times with length and height. So in this one, width and height, we're going to use 2 and 3. So that's going to go there and here. Okay, so just simplify it. 12 plus 8 plus 6, and we're going to times that answer by 2. So the surface area, surface area is going to equal 12 plus 8, which is 20, plus 2, which plus 6, which is 26, times 2, which is going to give you 52 centimeters squared. So that's going to give you the total of this whole shape when it's unraveled. Okay, it's going to be the same when we have this one here. So I'm just going to delete that bit there. So in this case, we know that rectangles have 6 sides. In this case, this is a cube as well. So therefore, it's going to have 6 equal sides. So the area of each side is the same. So in this case, we're going to use just a really simple one here. 6 times length squared. Now, this is length, so squared because it's counting this one and this one. Okay, but we've got 6 sides. So we're going to just assume that length equals, in this case, 2. Okay, so in this, we're going to have total surface area equals 6 times 2 squared. Okay, we'll simplify that, equals 6 times 4, so we have 24 centimeters. Nice and simple. Okay, moving forward. Okay, we're going to pause that there for you.